Hi, this is Kevin Trainer, and I'd like to welcome you to my uh, lecture on activity diagramming. This is something that I assign in connection with my project management courses. And currently, my project management course, we're using the eighth edition of Information Technology Project Management by Kathy Schwalbe. And this is material that's covered in Chapter 6, Time Management. And it has to do with doing the calculations for the critical path method by hand, which is not a thing that people do a lot anymore. Um, and that's because the software to do this in an automated way is very affordable. And but um, it's a great way to learn about the kind of thinking, the kind of calculations that go into this kind of technique. So if you really want to kind of understand the answers that are being generated by automated planning tools, then you're going to want to at least understand the principles here. And if you are a project manager who's going to go for their PMP certification, well, then you need to be able to do these by hand in order to answer some significant subset of the questions on the PMP exam. So uh, I have created activity diagramming exercises here, and what I'm going to do is walk through them and have you follow along. If you want to do these yourself, what I do is I have a point where I pause, and then you can stop there before the spoiler, okay? And you can do the work yourself, and then you can check yourself by playing the rest of the video and or looking at the rest of the slides. So there's a follow along part, and then there is the exercise where you could do it yourself. Okay, so let's begin. Here is a typical activity on arrow diagramming diagram. And this is exercise one, where I walk you through it. And particularly in the Schwalbe book, they make a big deal about the difference between the activity on arrow technique, which we see here, and the precedence diagramming it technique, which is usually the kind of diagram that gets printed out if you're using an automated tool. And the nature of the difference is the precedence diagramming technique allows you to express some dependencies among the activities that are more sophisticated than your standard finish to start dependencies. But regardless of which way you draw your diagram, if you're going to solve it by hand, you can really only have finish to start dependencies. And so I tend to favor the tried and the true, and that's why I use the activity on arrow technique. Um, so here we have a group of activities that we need to get the project done. So on the left side, before we encounter the first circle or node, we haven't started the project yet. And then we start the project, and there are three tasks that could be started at the same time: task A, task B, task C. The task A, we expect to have a 6-day duration, task B, 5, task C, 7. And then as we go down across the diagram, the nodes that we introduce just really show the dependencies. So between tasks A and D, we have a node. that indicates we have to finish task A before we can start task D. Some of the nodes have more than one task arrow feeding into them. So for instance, here in the very middle of the diagram, we have to finish tasks E and F before we are able to start the activities that come out the other side, H, I, and J. So that's how the logic of the diagram works. Okay. So typically what we do when we do this technique by hand is that we calculate 4 values for each of the tasks or activities. Early start, early finish, late start, late finish. And we do this by going through the diagram in 2 passes, one from left to right, which we call the forward pass, and one from right to left, which is called the backward pass. So we do the forward, in which we calculate early start and early finish. Then we get to the end and we turn around, we do the backward, where we calculate late finish, late start. Okay? So how does this work? Well, the other thing is that when we're doing a forward pass, we're doing some math. Okay? So we're trying to figure out, based upon the early finish of the tasks that are coming into this junction, what should the early start be for the tasks that come out? And in the forward pass, when we're going from the left to the right, we take the highest of the values that are coming into the node, and we use that as the value going out of the node. So you can see that of 21, 17, and 18 coming into the node, the highest is 21. So that becomes the early start of the activities that are coming out of the node on the right-hand side. Okay, so let's do a forward pass and let's see how this goes. There's a lot of calculation, and I've kind of color-coded it to help you follow along. So we begin with task A. It has a duration of 6, and the early start for all of the tasks that start at the beginning node is day 0, and then we add the duration, so we get the early finish of 6. So that's the reason why we have a 0 at the beginning of the arrow for A and a 6 at the end. And then for B, the duration is 5, so it's early finish of 5. And then for C, we have a duration of 7, so we have an early finish of 7. Now we're just going to go up and do D. So the early start is just a copy of the early finish that came into the node. Okay, so if we came in with 6, we go out with 6. So early start of 6, duration of 2, early finish of 8. And now down here with task E, again, early start of 5, which we inherited from the early finish of B being 5. So 5 plus 11 is 16. And then down on task F, 7 plus 8 is 15. Up at the top again, G, 8 plus 6 is 14. And now we're starting to come, we're looking at task H, and it's a little bit more complicated to figure out the early start for H, I, and J. We look at the early finish of the tasks that are coming into, and in this forward pass, the left to right one, we take the highest of the numbers, 16. So you can look on the right hand side, and you can see that the early start for H, I, and J are now 16. So for H, 16 plus 2 is 18. For I, 16 plus 3 is 19. For J, 16 plus 5 is 21. And then we come up to K, all right? And so there are two activities that are coming into the node that K comes out of, and their early finishes of 14 and 18. So again, we take the highest. So early start for K is 18. 18 plus 7 is 25. So across that path, the early finish is 25. And then let's look along the bottom here. We look at L, where we have an early start of 21 plus 11 is 32. So the early finish on that path is 32. And then finally, we already do I? No? Yeah, I think we already did I. I'm sorry. So we already did I at 19. So if we look at the tasks that are coming into the final node, they have early finishes of 25, 19, 32. Far and away, the highest of those is 32. And so the total, the amount that we take across the other side is 32. So this becomes, the 32 is the early finish for the project. Okay? That is the earliest we can possibly get it done is 32 days. All right. Now, let's do the backward pass, and this is where we learn about things like slack and float. Okay, so when we're making the backward pass, okay, it's going like this. We're going from right to left, okay? So we're looking at the values that are coming into the node. So on the right hand side, 16 coming in, 11 coming in, 19 coming in. And here, because we're going the other way, what works is to take the lowest of the values. So it's 11. So that's the late start is 11, okay? And then we come over to the other side of the node, and we have to populate the late finish. And of course, we take the lowest of the values coming into the node, which is 11. So the two on the left get a late finish of 11. Okay. So let's kind of work this back. So we're starting with 32. Right? So 32 becomes the late finish of all three of the tasks that go into the terminal node K, I, and L. And then if we look at L, we start at 32, we subtract 11, we've got 21. Now I just want to point out that there's no difference between the early start and the late start, and this means that there is a slack or float of 0, and this means that this is a test that's on the critical path. Up on I, 32 minus 3 is 29. On K, 32 minus 7 is 25. Down on J, 21 minus 5 is 16. On H, 25 minus 2 is 23. And how did we get the 25? Well, that was the only task coming into that node, so that makes sense. And then up in G, it's the same thing. It's 25 because that was the late start coming into K. Okay, so there's a late finish for G and for H of 25. So 25 minus 6 is 19. Now we're seeing slack or float. So we're seeing that task G has a slack or float of 11. That's a lot of slack or float. Whereas task K had a slack or float of 7. Okay? So that's how we're going to figure those out. D, late finish of 19 minus 2 is 17. We still have a slacker float of 11 on that path. Down on E, late finish of 16 minus 11 is 5. No difference between the late start and the early start. That's on the critical path as well. No slacker float. On F, late finish of 16 minus 8 is 8. Difference between 7 and 8 means we have 1 day of slacker float on that path. Up to task A, late finish of 17 minus 6 gives us 11, so that difference between 11 and 0 is the slacker float on that path. On B, 5 minus 5 is 0, no slacker float on that path, that's on the critical path. And C, 8 minus 7 is 1 day of slacker float on that path. So then we look at the 3 paths. So the path with 0 is the one on the critical path. So the critical path begins with B. The path that begins with C has 1 day of slack, and the path that begins with A has 11 days of slack. And if you want to know the critical path, the one that adds up to the 32 days, it's BEJL, and BEJL is the critical path. It's the longest path through the network. It adds up to 32, and 32 days is the shortest number of days in which we can complete the project. Okay, so now exercise 2. This is your chance to do the work yourself and check your answers on the next one. Okay? And that's why there's a spoiler warning for exercise 2. So there's a spoiler warning in the slides. Now there's a spoiler warning in the video. So pause here if you want to solve this one yourself. Otherwise, here we go. So here are all the calculations, and then we'll walk through them, right? So I'm sorry. So we do see that the slack at the end of exercise 2, the path that begins with A, 0 slack. The path that begins with B, 3 days. The path that begins with C, 12 days. So the critical path is starting with A in this one. And the critical path is ADHL. And the earliest that we can get the project done is 28 days. So that is the longest path through the network. It's the critical path, and it's the shortest amount of time in which we can accomplish our goal. Okay? So that's it for activity diagramming. I'm glad to answer any individual questions people have. So I'm going to put that out there, and I'm going to say bye until next time. Bye-bye.